Hello everyone, very warm welcome to all of you on the platform of KSG India. My name is Akhilesh. Today I'm going to discuss about the origin of universe, and this topic is equally important for geography optional as well as general studies topic. So let's begin with Big Bang theory. This Big Bang theory is basically given by George Lemaitre. He was a father in monastery, and he gave this idea about the origin of universe, because there were so many in theory, but this is going to be the most accepted scientific theory which has certain kind of evidences. Later on in the history of science you will find it is supported by some evidences which was solely based on science too. That's why this theory, the Big Bang theory, is most acceptable, and it is assumed that it is very close to the truth, because the evidences like Edwin Hubble's redshift as well as uh, genesis of Higgs boson experiment, it was done in Europe by experimenting this large hadron collider experiment over there, and this kind of genesis was supported by the results from the science also. That's why this theory is going to be most acceptable theory. So let's begin with this Big Bang theory. So according to this theory, there was nothing. Nothing means there was no matter, there was no time, no space, even there was no light, because the light is also made up of photons, and as there was no particle, so there was nothing exist over there. What was there was a hypothetical small ball where all the things were concentrated, and it was named singularity, and this singularity was very small in size. It was very small in size, of few centimeter diameter. This was named singularity. Fine, everything was concentrated over here, just few centimeter of diameter. It has infinite gravity, infinite mass, infinite density. In a tiny volume, packed in a tiny volume. And that too, if we compare the temperature, temperature is also going to be infinite. So many infinite things. We can compare this singularity as today's supercharged black hole. Supercharged black hole. At that very time, this concept was not there. Supercharged black hole, this is the modern concept, but this singularity can be compared as supercharged black hole. Everything was concentrated over there, and all of a sudden there was an explosion. What was the reason of explosion? It is unexplained, but yes, there was an explosion, and this explosion have taken place almost 13.7 billion years from today. This event is called as Big Bang, and we call it Big Bang. So what happened after Big Bang? Everything which we are now watching, we actually exist. Everything was formed after this Big Bang. So what happened after just after this explosion in the singularity, the energy was released, and some amount of energy was converted into mass. It happened first time in the history of universe. Energy that was released, some amount of energy, it was converted into mass. Energy converted into mass. And we know that there is a relationship between energy and mass. It was given by Einstein, E is equal to mc square, and this is giving the relationship. through which mass can be converted into energy as well as energy can be converted into mass, where M stand for mass, E stand for energy, and C is velocity of light. The fastest thing moving in our universe, velocity of light, and you have the idea, 3 lakhs kilometer per second. So this is what relationship between energy and mass. That means mass can be converted into energy and energy can be converted into mass. So what happened after just this Big Bang? Some amount of energy was converted into mass. It was happening for the first time in this universe. And after conversion of this energy into mass, the first particle that cropped up, that grew up was called as Higgs boson. Higgs boson. And this was later on called as God particle. God particle. Fine. Higgs, Peter Higgs was the scientist behind this discovery or this theory also, and he proved this idea by first theoretically he gave it in way back in 1960, but it was proved later in 2012 when Large Hadron Collider have given the same kind of origin of this God particle or this kind of particle if the simulation of the stages of Big Bang can be done artificially. So it was done in case of this theory that experiment, Large Hadron Collider experiment, LHC experiment, and in 2012 it was proved yes, energy can be converted into mass, and the mass which was created was Higgs boson. Although this was proved by Einstein, but the thing कि God particle like particles were originated after Big Bang was proved in 2012. For this person Peter Higgs was rewarded Nobel Prize of Physics also. Fine. So now the time we have this idea that there was a singularity, again I am repeating it, and it was having infinite gravity, infinite density, infinite temperature, and all of a sudden there was an explosion and everything was started expanding. And meanwhile what happened, some energy was converted into mass and there was formation of God particle. God particle. Fine. These God particle are Higgs boson recombined to give rise to quarks and neutrino. Quarks and neutrino. And these quarks and neutrino further combine to form subatomic particle that is called as electron, proton and neutron. The process of formation of these particles has been started just few minutes after Big Bang. There was explosion and the expansion was going on. In the meanwhile, in expansion, energy was converted into mass, and in which form? God particle. And these God particle gave rise to quarks and neutrino. A recombination of this quarks and neutrino was in form of subatomic particle, that is what? Electron, proton and neutron. Fine. You know that if you have the basic science understanding, you have this idea, the electrons are negatively charged, massless particle that is orbiting the nucleus, and proton and neutrons, they are also called as nucleons, they are residing in the nucleus of the atom. And after formation of these electron, proton and neutron, the first atom that was formed was helium. Helium was the first atom which was formed. Fine. Two protons inside the nucleus, two neutrons inside the nucleus, and there was two electrons orbiting the orbit of this helium. This was the first atom which was formed after Big Bang. Yes, it has taken almost 300,000 years. 300,000 years after this Big Bang. So this was the first atom, and simultaneously with helium there was formation of hydrogen also. So hydrogen was the second atom that was formed. Helium was the first atom that was formed. But what was there? The hydrogen was formed in abundance and helium in less amount. So hydrogen in abundance, and there was formation of helium that is much less than the hydrogen. That means whatever was expanding is not just few particle, it is now changed into atoms, but the expansion was going on. This expansion was going on, and simultaneously the gases, this stage is actually referred as nebula phase. Nebula phase. So what happened? The expansion was going on, and as the gases were created, this hydrogen and helium were created. So they are having mass, and due to the mass, they acquire gravity. So under gravity, they are expanding and simultaneously they are coalescing too. What I said, they are expanding and simultaneously and they are grouping also. They are creating groups, coalescing too because of their own gravity. So under their own gravity, they start accumulating, and not only accumulating, but they are also expanding with each other, others group, but coalescing within its own gravity. So you'll find this kind of cluster formation have taken place. This is basically gaseous nebula phase. But what is special in this gaseous nebula phase? Because gases are having mass, and due to the mass they have gravity, so they start coalescing in under their own gravity. They start concentrating under their own gravity. Not only this, they are concentrating at one place, and these three are expanding with each other. With respect to each other, they are expanding, they are going away, but they are concentrating under their own gravity. So in this gaseous nebula phase, you will find different clusters of gases which has a kind of grouping of gases, clusters of gases which were accumulated because of their own gravity. So due to this gravity, they have started creating groups of gases. Which gas? Hydrogen and helium. What else? After this, let me take one of the cluster out, and this each cluster is going to be transformed into galaxy. And you will get mesmerized to know that our universe is containing billions of galaxies, and each galaxy containing billions of stars. One of the star, average size star, is our sun, and the solar system belongs to this average size, or you can say small size star, that is our sun. So just like our sun, there are billions of stars in our universe. So you can understand how big this universe is. Fine. So let's take up this one, and let me give you idea how the galaxies are and how the stars were born. So if you see this entire grouping of the gas, which is made up of hydrogen and helium, abundance of hydrogen, less helium, almost more than 90% was hydrogen, and less than 10% was helium. You can have this kind of uh, uh, amount which was present over there. Fine. You will find there is a differences of some kind of these percentage are amount that has been given from one book to other book, but the thing is there was no one to estimate it. It was just a hypothetical hypothesis, and it was supported by certain evidence. That's why it is a theory now. Fine. So let me take it on other page of the board and tell you what exactly happening over there. So let's consider this, the nebula of the gases, which will later on get transformed into galaxy. There will be a center, and the center of this galaxy is going to be occupied by the black hole, which is the biggest black hole of that very galaxy, are called as central black hole. What is happening in these gaseous cloud? These are the gaseous cloud. Let's take up a small amount of these gaseous cloud on the other page of the board, and I will tell you how the stars were born. Fine. So these gases containing hydrogen and helium. What happened? This hydrogen and helium gaseous cloud has a core, center, and surrounding cloud is now pressing this core from outside. This is the gravity that is pressing the core. Gravity of gaseous cloud. Gaseous cloud. Fine. This gaseous cloud is pressing the core, and under this superincumbent gravity, core get pressed. Inside the core, what is there? Inside the core there is hydrogen as well as helium. More hydrogen and helium. It is now pressed from all sides by the gravity. And due to this, what happened? The core start crunching. The core start getting reduced in its volume. And what happened to this hydrogen and helium? They get less volume, so they start colliding with each other. So after this gaseous cloud and the gravity, there is a core crunching, and due to crunching of the core, volume of the core get reduced, and that lead to collision in the gaseous atoms. So there will be collision, and this collision was started, and due to the collision, what happened? The temperature of the core start rising up. I am reflecting this as a core temperature start rise up, and this rise up is getting more intense as the gravity is continuously pushing this core, and this temperature reaches up to 10 to the power 7 degrees centigrade. This is the temperature of the core, and it's a very special temperature. At this very temperature, the small hydrogen nuclei start fusing into large helium nuclei. That means nuclear fusion reaction get established. Nuclear fusion reaction. Nuclear fusion reaction get established inside the core. And due to this nuclear fusion reaction, what happened? The core start emitting radiation. The core start emitting radiation, electromagnetic radiation. That is what the energy, the solar energy which we can feel on the Earth's surface, the ultimate source of energy. This electromagnetic radiation start emitting from the core. And this is the stage when we can say that there is a new star that is born, and it is going to be the protostar stage. Protostar stage. So this is the stage or the formation of protostar that happened almost 6 billion from today. That means if you compare it from 13.7 billion, so you can calculate the time. This was the time of origin of the stars, formation of the galaxy, and sun is one of the star. Fine. So this protostar, it has another name like embryo star. Embryo star, it was formed, and this embryo star start radiating this radiation energy from the core. How this core get fired? Because of nuclear fusion reaction. And for nuclear fusion reaction, what is required? Requirement is what? Very high temperature, that is what, 10 to the power 7 degrees centigrade. Second thing, there should be hydrogen. For hydrogen is going to be fuel for this reaction, so there should be hydrogen, and the hydrogen inside the core is going to be heated up 10 to the power 7 degrees centigrade. From where this heat came from? It is because of the collision of hydrogen. Why the collision? Because of the gravity of the outside cloud. From where this cloud comes? Indeed, it is because of the formation of atoms, formation of hydrogen and helium. From where they came? Formation of electron, proton and neutron. How this was formed? Indeed, it was because of the quarks and neutrino combination, which was ideally formed from the God particle, and it was created after energy converted into mass. This is the story you should have on your fingertips. And after that, what happened? This protostar will not remain protostar. It has to be mature because the star was born. So this star will reach to its stardom, that is called as mature star phase, and other phases are also there. We will see eventually in this program. But indeed, I want to tell you exact positions of these stars on the galaxy. So we were talking about this gaseous nebula phase, and I said to you there was a center. This is the center of the star, and around this center the entire galaxy is actually revolving around this central black hole. So let me give you idea of the galaxy, how the galaxy is there and how the stars are arranged over here, and then I will tell you the story of the star. Let me give you the idea of galaxy. Fine. So from here the protostar story is going to be what you just keep it holding, and let me complete the galaxy, then I will come on it again. Fine. So as I told you, the center is going to be occupied by the black hole. This is the black hole of the galaxy, and it remain black. It will be I'm just showing it with black because there is nothing visible around it. It is of infinite density and very high gravity. That's why it wobble the time space continuum, and it occupies mostly the center of the galaxy. Then you will find that the protostars are born on the outer arm of the galaxy. You are going to have three arms of the galaxy: the inner arm, the middle arm and the outer arm. So in this case, here you are going to have outer arm, here it is the middle arm, and this is what inner arm. Fine. In other book you will find zone over there. I am just calling it outer zone, middle zone and inner zone. A new star is going to be originating over here. So this is the place of new star, or embryo star. Our protostar is going to born over here. Further, this embryo star orbit this galaxy in anti-clockwise direction. So you will find this direction is going to be counterclockwise direction, anti-clockwise direction. Entire galaxy is orbiting this central black hole in anti-clockwise direction. Anti-clockwise direction. Fine. This anti-clockwise direction is going to be the direction of the revolution of galaxy, and this embryo star is revolving. Not only embryo star but mature star and older stars are also revolving around the galaxy in anti-clockwise direction. The outer arm is occupied by the embryo star, and the middle and inner arms are occupied by the mature stars. These happen to be mature star. For example, in our case we have mature stars like sun. Our sun is mature star. We have mature star like Polaris, that is what mature star. So you will find like this is our sun. Fine. Suppose that this is another mature star. I am giving you the dog star, the Proxima Centauri. We can name it Polaris, ध्रुव तारा जिसे आप कहते हैं. So these are present on the middle arm of the galaxy. Fine. embryo star, then mature star. And after mature star, they are going for their latter phase of the life, in which you are going to have white dwarf stage, black dwarf stage. Sometime the star is going to be very massive. Massive star can also be there, which is like, which is uh, 50 times, 60 times larger than the sun. These massive star is going to have different kind of stardom. So their end is a little bit different, and this difference was given to you as a concept by Subramaniam Chandrasekhar. We talk it in later classes. That is what Chandrasekhar limit. Fine. So these mature stars of varying size occupies the middle arm, and in the latter phase of the life of star, you will get red giant phase, then you will get this supernova phase. Ultimately you will find this white dwarf, and latter there will be black dwarf that is surrounding the black hole. So these are the phases which you will find in the latter phase of the star, that is going to be near the center of the star, and they are called as like white dwarf. And here it is black dwarf, white dwarf and black dwarf. This is a mature star. I have just given you the difference in the size. It is of very large size, means 40 times or 60 times larger than the sun, larger than sun. So this is something you can expect in our galaxy. Yes, we do have massive star, much bigger than the sun. So you'll find these massive star happen to be at the middle arm. These are what white dwarf, and ultimately the black dwarf, that is what the last stage of the star's life. And when this massive star going to collapse, it will form supernova, and then supernova to a neutron star. So it is creating neutron star, that is also called as pulsating star, pulsating star. Fine. So this is a typical structure of a galaxy, and I told you about the Big Bang theory. So up till now we have some kind of support that can substantiate this theory should be known. So what kind of support in the Big Bang theory in means substantiating this theory is going to be scientific and very scientific. So let me explain the support evidences in support of Big Bang theory. In support of Big Bang theory, first one is redshift. Redshift. It was basically given by Edwin Hubble. Edwin Hubble. He was a great physicist, astrophysicist from NASA, United States of America. Way back in 1920, he gave this concept of redshift. According to this redshift, he said the universe is expanding. Universe is expanding, and it was proved by this phenomena of redshift. Expanding universe theory. That's why Big Bang theory is also called as expanding universe theory. Fine. What is a redshift? If you have the basic idea of science, so you know the Doppler effect. What is in Doppler effect? If the source is moving with respect to observer, certainly the amount of energy released, or you can say wave produced, is going to have different type of perception. Take an example of a train which is coming towards you. The train is coming towards you. You are going to be the observer. The train is coming towards you and it is blowing its horn with the intensity, and the train which is going away from you is also blowing the horn with the same intensity. What is going to happen in case 1 and in case 2? You'll find in case 1 the sound is perceived increasing, while in case 2 you will find the sound is going to be diminished. Why it is going to happen? Because of the relative motion. Relative motion. So I'm not going to indulge my nose in the science, just giving you this idea and that this is going to be the Doppler effect. What does it mean? If the source which is producing the sound is a wave, is going to be under motion, the perceived frequency of that very sound or intensity is going to vary. If it is coming towards you, it is on increase. If it is going away from you, it is on decrease. Similarly, as you know, the light is also going to be what? Energy. It is produced by the star in form of radiation. So the light which is coming from the star, if going to have a trend which shows diminishing trend, so what does it mean? That means the source is moving away from us. Let me explain with the figure. You all have this idea that visible light which is 400 to 700 nanometer is going to have colors. We all have this idea. Violet, this is the spectrum of light. Fine. Violet, indigo, blue, green, yellow, orange and red. And you all have this idea that violet is going to have 400 nanometer wavelength and the red is going to have 700 nanometer wavelength. Not only this, if we compare the energy is going to be higher, and as the wavelength increasing, energy is going to be lower. Fine. Suppose that any star which was emitting blue light, say for example 20 years back, this star was just a blue star. Same star was a blue star, and you are the observer. Observer, that means we are on the earth's surface. We are observing this star as a blue star, and the same star after few time or few years it become orange. Same star is becoming orange. Same observer is observing this star from the earth's surface. Same star is now orange. Earlier, few years back it was blue. So what will be the conclusion? That the energy which is coming from the star is day by day is reducing or getting lower. That means earlier it was blue, now it is shifting towards red, isn't it? And that's why this phenomena is called as red shift. So red shift occurred, and this is giving the idea that universe is expanding with respect to each other. We are as an observer on the earth's surface. But what about these stars? With respect to earth, they are going away. That's why when they were blue earlier, say for example 20 years back, but now same star is going to give what you can say orange light or red light. So there is a shift towards red, and this phenomena was observed in our universe, in our galaxy, and it has been given the name red shift. So Edwin Hubble said that red shift is going on, and this is something that's substantiating the Big Bang theory. Anything, if it is expanding, can be expanded only when they are somewhere at the same point, somewhere in the past. And this Edwin Hubble's theory of redshift is supporting the Big Bang theory. Fine. Another best example we can cite from Large Hadron Collider experiment. This Large Hadron Collider experiment is taking place at the Switzerland-France border way back in 2000 and 2000 onwards. This was started. It was an underground experiment, and there was a objective to simulate the Big Bang type of situation. Means simulation of Big Bang type of situation. And what was done by using particle accelerator, particles were accelerated at very high speed, almost equal to light, and they were happened to be collided. And when these particles collided, the situation was just like the Big Bang. And it was when analyzed, they found that this Higgs boson were generated. Peter Higgs already discussed this Higgs boson way back in 1960s as a theory. But it was proved in 2012. His theory came to be what? I mean, it was now become theory because it has certain evidence and scientific evidence. And that's why he was rewarded Nobel Prize of Physics. Peter Higgs. Fine. These two evidences are very much supporting the Big Bang theory. I hope I made my point clear to you. Thank you.